FEs that are going to come up. We have sine of x over x. Now, how are you going to remember those?
Because you say two zeros. You don't want to go.
Thank you, Sarah. Say that again. Yeah, you need to remember what that shape looks like. That's that kind of like this. Okay? All right, so just because otherwise it's kind of random. All right, I know that in itself is kind of random. But let's take a look at the next page that you have. I'm not going to minimize that because then I'll forget about it. Let's take a look at, not that, where is it? This one, okay? All right, use the definition of derivative to find. Okay, so this is f of x plus h minus f of x all over h, limit as h approaches 0. Okay, where does this come from? The rule, what? The sum difference identity.
Right.
Okay, so, all right. Then what is happening down here? I see this right here, and then this is just rearranged. Got it? Because that's that, that's that, that's that. Okay, so just rearranged. All right, now look at here. What's happened here?
Pulled out the sine of x for the first half and separated it.
Right. This is just this, right? And then this is that right there. Okay? Now, this is another identity that rarely comes up, but let me just talk about it here. The limit, rather. So I didn't even really go there with it because I've never seen it really come up. All right, so that identity, can you guess what it is according to what's below on the step? Okay, so the limit of the product is the product of the limit, so that's what this is. I'm separating this out. There's that step, you can't guess yet. And then again, here's the sum of the limits. Okay, did I lose anybody on that yet? What side you put away?
The side that you just wrote, like a little. Sorry. You just wrote.
No, I haven't yet.
Oh, okay.
Okay. So all I did was rearrange and then split up so I could use these common. This one is definitely common. This one, meh. It looks like there's an extra parenthesis here too. Okay. So now you got the limit of the sine of x. There it is. Here's this limit. That's 0. Okay. Just take my word for it. We'll look at it later if you're dying to. Limit of, as h approaches 0, cosine times that limit is 1. That's the one we just talked about, right? Okay. Now, what is anything times 0? 0. And then the limit as h approaches 0 of cosine of x is, what does that equal? If you plug in h for 0 for h, are you getting 1? 0 is h. There's no h in that cosine of x.
Oh, so it's just limit cosine.
No, it's cosine of x. Okay, so bottom line, derivative of sine of x equals what? Cosine of x. Okay? We did that when we were looking at increasing, decreasing concavity and 2.8. Yes, we did. Okay? All right, so we are going to just remember that. Unless you, of course, want to go through that every time you want to figure out the derivative of sine x. I don't think you want to do that. The answer to this is 0, but again, it doesn't come up, so I'm not even really going. I didn't really go there. Okay, so let's talk about all the other derivatives, shall we? So we got sine. we need to look at cosine. I'm going to put that one over, maybe not. I'll put that one over here. There is a method to my madness here. Okay, I'm going to put tangent here and secant here. Okay. Cotangent is here and cosecant is here. Dang it. Okay. All right. Now, I put the co-functions, the ones that start with co, over in the column for a reason. Okay. Okay. All right. We already know the derivative of sine is cosine, so we'll go ahead and fill that out. Okay. The tangent is secant squared of x. Okay. And secant is secant x tangent x. Now, there's a whole big long reason, just like we did the reason for cosine and sine, that we can go over if you don't want to, but I really don't want to. Okay. All right. Okay, good. This is negative sine of x. And remember we ended up talking about that too when we talked about that same thing. Cotangent is negative cosecant squared x. And cosecant is negative cosecant x cotangent x. Okay. Now, tell me why I grouped them like I grouped them. That's right. All the functions that start with co in their words. I know we talked about sine and cosine being co-functions, but that's not what I'm talking about now. All the trig functions that start with a co in front of their names are of the derivatives are all negative. Okay? No. Okay. So memorize these sooner rather than later. Okay? All right, now we're just adding a layer of trig functions now onto the product rule, the quotient rule, all that good stuff. Okay? So, you ready for some examples? I'm just going to keep this on dual page so that we can refer to them because I know you don't have it memorized quite yet. All right, so let's find y prime if y equals x squared sine of x. All right. Okay. Tell me what rule I'm going to start with, Libby.
Those are the derivatives multiplication.
What do you mean multiplication one? Okay, there we go. There's the word I was looking for. Okay. So spell it out for me, Caitlin. Spell out that product rule. You can, yeah. If you like that single in front, you can switch that around. All right, the product rule doesn't get weird, but if you don't do the product rule that way, then you might mix up the quotient rule. All right, now, some people do not have to write that stuff out. They go right to this step, which is our whole goal. What's the derivative of x squared, Ainsley? Okay, so if you knew that, you jump right there, okay? And the derivative of sine squared is what, Riley? Or sine of x, sorry. Okay. Now, I can be done, okay? depending on what I'm going to do with that, I might want to factor it. What does the factor look like? X, and then 2 sine of x plus x cosine. Now, if I'm not doing anything with it, I wouldn't go there. But if I was going to solve it for, like if it equals 0, and I was looking for negative or positive, but typically, if all I'm doing right now is the technical, I would stop right there. Okay? Also, remember, let's say we want y prime at pi over 2. Okay, so that means we would do that first. And then we would plug in pi over 2. Okay? Right? So, 2 pi over 2 sine of pi over 2 plus pi over 2 squared cosine pi over 2. And then we do the simplifying. Okay, 2 cancels. And what's the sine of pi over 2? 1. So pi times 1 plus, what's pi over 2 squared? Thank you. And cosine of pi over 2 is? So the final answer is pi. Okay, that's if we were evaluating at. But you, just like anytime else, you find the derivative, then you plug in. Now, you can plug in when you're cleaned up, or you can plug in at any point. I could have plugged in, if I knew that that was not what I was doing, I don't have to spend the time, cleaning up, I just plug it in. Okay, good? All right, oops, that's not what I want to do. Okay, so next example is y double prime if y is secant theta. Now remember, theta is just your variable. Okay, so you can't just jump right into double prime. We're going to start with prime. So y prime, consult your thing there. All right, there it is. The derivative of secant is secant theta tangent theta. Okay, that's the memorized one. Now, what are we going to have to do with secant theta tangent theta? All right, set it up for me, Sarah Jones.
Secant theta
Okay.
times tangent theta plus tangent theta prime times secant.
Okay. Okay. Now, it's up to you whether you need to write that or not. Okay, secant theta prime, again, Sarah Culp is? I'll ask you first. All right, plus tangent theta is, derivative is secant squared. Okay. Lots going on. What do we got? If we wanted to, we would for sure write tangent squared and secant cubed. We could go on, but that's good enough. We're not doing anything with it other than, making it. Okay. Now, let's apply that. This is 2b. Find where y is increasing and decreasing on interval negative half pi to half pi. Okay? I might just add another page. Okay? Got 2B. All right, so remind me again, where is y decreasing? What do we know about y prime?
One is negative.
Negative, okay. And y is increasing where y prime is positive. Okay, so that's what we're after, where y prime, that ugly looking thing down there, is negative and positive. So probably where should we start? If we want negative and positive. What's in between negative and positive? 0. So let's start with y prime equals 0. So this mess equals 0. Okay? That's double prime. Oh, you're right. That's even better. Secant theta, tangent theta. Good catch there, circle. Okay. All right. So what could we, if we were checking y double prime, what would we be checking for? Just concave. Good job. Okay. So how do we solve 0 equals two things multiplied together? Okay, good. So secant theta equals 0 or tangent theta equals 0. Remember, you're on this interval here. So where secant really is right. Okay, so let's start with tangent, because here's negative half pi to half pi. Where's tangent equal to 0? Tangent, remember, is sine over cosine. So what are we really after for zeros? Sine or cosine? To make tangent 0. Sine, good job. So in this era, what's theta? That tangent's going to be 0. 0, good job, Sarah. Okay. Because it's going to be 1 here, it's going to be negative 1 here, it's going to be something in between that. So, all right, so we got 1 solved. All right, how are we going to do that to be same area? This guy right here for this secant business. If secant is 0, cosine is undefined, right? I mean, cosine, 1 over cosine is 0. Cosine is going to be undefined in that area. Okay? I mean, I'm asking you. Is there anywhere in that area that we won't have a cosine? No. Okay, so there's no values here. We only have 1 then. Okay? Cosine is defined everywhere here. Is cosine ever not defined? Cosine theta goes on and on and on and on and on and on and on, right? Either direction. Okay? If you had cosine of 0, let's talk about this. That would make secant undefined, right? We don't want that. We want secant 0. Okay. All right. So we have 1, 0. Let's do some interval testing. Negative half pi to half pi. Here's your 1, 0. Okay. All right, your 1, 0. We're going to check this guy and this guy. And when I say check, remember we are looking for, dang it, we are looking for f prime to be positive or negative, right? Okay, so we're going to check with f prime. All right, let's start in this 4th quadrant, because that's this section right here. This is the 4th quadrant. All right, what is the tangent in this 4th quadrant? Negative. Okay. All students take calculus. Tangent is negative because cosine is positive. Okay. What about cosine? Because it would have the same value as secant, right? Same sign, sorry. all students take calculus. So, okay, so a negative times a positive is going to be a
Negative.
negative. Does anybody need to hear that again? That was secant times tangent. That's going to be negative. Okay, about in here, isn't everything positive in the first quadrant? Okay, so f prime secant theta, tangent theta is going to be positive then, because everything is positive. Okay, so we've got our interval testing. F is increasing, where f prime is positive on what? 0 to half pi. Good job. Okay. F is decreasing, where f prime is negative on the other one, negative half pi to 0. Okay. Whenever you're giving a reason for increasing and decreasing, and you want a reason, that's what you want, where f prime is negative or f prime is positive. It's not because that's what the graph looks like. Okay. Anybody confused here? Are we good? What time are we going to lunch? Do we know? Yeah, sorry. Why did I pick what? Why did I pick what? Well, the problem told me that in the first place. Find where y is increasing on negative half pi to half pi. So that, yes, because otherwise we'd have to consider it all, and that would be like y. Okay, so let's get our calculator out and check out the original function secant theta. Okay, and remember to put in your window. This is your x window here. All right. So for y equals, let me get rid of all this mess here. Here. Okay, we want to do 1 over cosine. I'm going to make sure you're in radians. You should be in there regardless. You shouldn't be switching back and forth anymore, really. Unless you were doing ACT something. Did anybody do that over the weekend? Okay. And remember are you kidding? Okay, sorry. All right, remember the only variable the calculator recognizes is x. So don't try to put theta in, that's a polar. Okay. All right, window. We're going to do negative half pi. Pi over 2 to pi over 2. Okay, I don't care what my scale is because I'm not going to try to read it. I'm just going to make sense of it. Negative 10 to 10 probably is going to work just because it's, you know, that U-y looking thing. Okay. One of what things? All right, so sorry. Dang it. Okay. My graph looks like this. Okay, let's talk about the answer that we wrote down. F is increasing from 0 to half pi. Would you agree with this graph? 0 to half pi, it's increasing. And from negative half pi to 0, it's decreasing. Okay? So that's a pretty wide view, but that's what it looks like just on that one little interval from negative half pi to half pi. Okay, so that is verified. But that would not be a good enough reason. Your graph is not ever going to be a good enough reason to tell you why something's increasing or decreasing, unless they supplied the graph in the first place. Then you could. Okay. All right. Let's do another one. Okay. Find the equation. This is, I don't know what example we're on by now. 3. Thank you. Find the equation of the normal line which is anything but normal, at x equals 0. And f of x is cosine of x over 1 plus sine of x. Okay? So, where are we going to start? Finding what? Derivative. Okay? So f prime, and what rule are we going to use, Ruby? Quotient rule. Go for it. Set it up for me.
Minus 1 plus
Okay?
over 1 plus x.
All right. Y'all got it memorized already? See, I told you it wouldn't take long. It sticks for some reason. All right. Mackenzie, what's the derivative of cosine? Good job. And Emily, what's the derivative of 1 plus sine of x? Good job. Okay. All right. What do you want to do now? Yeah, I would not ever multiply that bottom out until I'm sure I'm not going to have any common factors. Do I have a common factor right now?
No.
Because the top isn't factored to this, it's not factored. Remember, that's not a factor.
Yeah.
So don't be canceling factors. So what should we do now, Sarah?
I think I 1 plus sine x to negative 4.
That's a bad idea because it's not. Why would you do that?
Because
Oh, you were thinking of one. You were thinking of an identity?
Yeah.
No, that's not an identity. Okay, so next. We're not plugging anything in. We're just wait. Let's remember what we're doing. X equals 0. So we could plug it in rather than spend the time to clean it up, right? Okay, let's do it. X equals 0. Okay? Now, if we were going to clean it up, what would we do?
You multiply things out.
Right, multiply things out. Okay, so here we go. Negative sine of 0, 1 plus sine of 0, cosine of 0, or cosine squared of 0, right? Let's write that down. So we could spend a bunch of time cleaning it up, but excellent idea. You don't have to. Sine of 0. Okay, on the bottom. All right, what's the sine of 0? Sine of 0, 0. Okay, so I got 0 here then. What's the cosine of 0? 1. So what's 1 squared? So is that a negative 1 on top or a positive 1? Good job. Okay. And then this is 0. 1 squared is still 1. So, okay. The negative 1 is what? That was my derivative value at x equals 0. So what does that represent as far as the, this is the slope of the tangent line. Okay. All right, so if the slope of the tangent line, what's the slope of the normal line? 1. Opposite, reciprocal. When you reciprocate 1, you still get 1. Okay, and then the opposite of negative is positive. Okay, so equation, state Captain Obvious here. All right, so I got my 1 in its place. My 0 should go in here. Now, I don't have a y value. Plug what into 0? Okay, so right here, f of 0 is what I am interested in. So cosine of 0, which is what again? And 1 plus 0. So what's that? 1? Okay. Then I get down here and do 1. I know. Oh, whoa, 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 whoa. I just did it pretty fast because we already plugged in the numbers. Okay. Okay. So then I'm done. I mean, how would you check out to see that it looks perpendicularly hard unless you did the normal tangent line 2? Because it's going to be perpendicular kind of to the curve, but depending on your window, it may or may not look great.
Would you be able to write the final location of the only line as just one line?
Sure.
Because I see
Yeah.
the situation.
Yes. You can always go there. You can always go to y equals 1. No, 1x plus 1.
No.
Yeah.
Oh, yeah.
Okay? You can always go there. Just know that if you go there wrong, and that's your answer, I have to take off. And some of the multiple choice answers are also going to be in that form, so sometimes you have to go there. So it just depends. Good question. Okay? I'm really done.
What? Really?